Let's see this question. This question is asked in GATE 2013 in the subject analog. In the circuit shown below, what is the output voltage Vout if silicon transistor Q and an ideal op amp are used? Okay, given this is the circuit diagram, this is the silicon transistor Q and this is the op amp. They are saying that op amp is ideal. Now we need to find out what is the value of Vout. In the options given, A minus 15 volts, B minus 0.7 volts, C plus 0.7 volts, D plus 15 volts. Okay. Now if you observe this op amp, you need to find whether this op amp is inverting op amp or non-inverting op amp. If you see here, voltage is applied across inverting terminal. So op amp is inverting. So op amp of type inverting. Inverting op amp. Inverting op amp. Since it is inverting op amp, it provides 180 degrees phase shift. Phase shift will be 180 degrees. Phase shift will be 180 degrees. Now output is 180 degrees out of phase with respect to the input. Output is 180 degrees out of phase with respect to input. Out of phase with respect to input. So here input is 5 volts. Vin equal to plus 5 volts. So Vout output should be surely negative. Since input is positive, output will be 180 degrees out of phase should be negative. In the options given, option A is negative and option B is negative. So surely answer is either A or B. Now if you observe here, due to this down arrow mark, we can say that this transistor is of type NPN. NPN. Here P is connected to the ground and N terminal is connected to negative. So we can say that this transistor is in forward bias. Okay, forward bias, which means this will be in on state. This will be in on state. Now they also given that op amp is ideal. So op amp is ideal. Op amp is ideal. So for an ideal op amp, we know that voltage gain is equal to infinity. Voltage gain AV. Voltage gain AV is equal to infinity and input impedance Ri is also infinity. First we will take voltage gain. Voltage gain equal to infinity. It is nothing but V0 by VID equal to infinity. So VID is equal to 0. By this we get VID is equal to 0. Now VID is nothing but the voltage difference between two terminals of an op amp. So voltage difference between non-inverting terminal and voltage difference between inverting terminal is equal to 0. So V plus is equal to V minus. This concept is called virtual short. Very important concept. Due to this virtual short, both input terminals of an op amp will be at the same voltage. So if you see here, the non-inverting terminal is at 0 volts. So this also will be at 0 volts. Since plus terminal is connected to ground, so this also inverting terminal will be also 0 volts. Now we will calculate Vout. So if you observe here, the current passing through here is voltage is 5 and resistance is 1 kilo ohm. So current is 5 by 1 kilo ohm, that will be 5 milliamperes. So current flowing through the circuit is 5 milliamperes. So it will come here and at this point it cannot flow through this direction since Ra equal to infinity. So no current flows through this op amp. So it has to flow through this. And transistor is in on condition. So we can write Vout as the voltage difference from this point to the ground. So this point is emitter. So voltage at emitter of Q minus it is and ground is at base. So voltage at base to the ground. This is VEB. Okay. This can we can write this as voltage minus VBE. Okay. VEB can be written as minus VBE. Okay. Now for a silicon transistor, the base to emitter voltage is 0.7, which is a standard value. So Vout will be minus 0.7 volts. So this is how we calculated the value of Vout. So the answers option B it is minus 0.7 volts.